Guys, we start with the second and longer talk of the night.
Lenses.
Yeah, lens library.
Is it possible, maybe somebody else, to change my resolution? This is so tiny. I can't see what's going on.
Should we scale? Those are all on the section on the scale. Touch screen.
That's still
Because this is like a 14 program.
Could be.
We'll go with that.
Async are fine.
Let's start with the second talk and then we'll do the raffle.
I think pure functions are unasync. Pure functions definitely much easier on async because then you don't have to worry about inside.
This is absurdly good.
Simplistic view of a function.
Right.
Inputs and outputs. That's it.
Right.
Async basically suspends itself. It can actually put a value into it as well as the value out. Just one of the concepts is kind of extended.
All right, go ahead and get started then. Okay, so my name is Jason Stolaruk. You can call me Jason. You can also call me Stoly, which is what my coworkers tend to call me. I work at Detroit Labs, and I'm an Android developer. Did a little web app stuff for a while, but mainly Android is my thing. And at night, I'm a Haskell hacker. I have a game now that I've been working on in Haskell for 4 years, I think. It's I don't know if any of you have heard of this. It's a MUD, M-U-D, multi-user dungeon. Okay, we have some people over nodding their heads. That's great. So that's what I've been doing in Haskell for a few years now.
When you have a chance, can I get the title screen for your slideshow?
Oh, sure.
Archivist.
Oh, you need a picture?
Yep. There we go, thank you.
Yep. There's my email and whatnot. But yeah, today we're going to be talking about the lens library. So first of all, one more thing about me. I really like guinea pigs. And this picture is, I tend to like it because it's totally absurd. It's a guinea pig in plate armor. But I find guinea pigs to be very soothing in the age of Trump. Very reassuring. They are my emotional support. So I have 3 of them at home. So as an aside, that has nothing to do with this talk. So we'll move on from guinea pigs now. But yeah, so I'm wondering about the audience I have here today. So how many of you have written some Haskell before? That's a lot. Maybe half. Okay, so how many of you have heard of this lens library that I'll be talking about? Got a few hands. Have any of you actually used it? Have you used it at work?
Yeah.
Really? Okay.
Jason, I've heard of lenses, but not in terms of Haskell, but like conceptual idea.
Okay. So good. I'll try to give the presentation, keeping in mind that not everybody knows Haskell, so hopefully we won't have too many stumbling blocks on the syntax and things like that. So today I've got a few slides, but mostly I'm going to jump into the REPL and show you how this library is used. But before we do that, let's just discuss what are these things, lenses. So in terms of functional programming, lenses are getters and setters. It's kind of a different concept than the getter and setter that you might have your Java IDE auto-generate for you, but somewhat similar. Mainly they are a way to poke around inside data structures. And when I say data structure, there's a bunch of data structures, anything that you can think of pretty much they've tried to make lenses for, so be it a list or a map in terms of a key to value pair map and your nested record data types. So when I say getting and setting, when you have a data type that may be nested or complicated, you can actually get a particular piece of data in the structure that you're interested in, isolate it, pull it out, or you can set it, which means you may have a complex, say, record structure, and you want to manipulate or update or do something with one record. So you can update one record, one piece of the data, and get back the whole structure with that one piece having been updated. So that's the main idea. And this, this particular library that I'm talking about, Lens, is, I think it's the most popular Lens library for Haskell, but it's not the only one. When I first started getting into Haskell maybe 5 years ago, it was extremely popular. Everyone was talking about it. I think it's still quite popular. And it's quite complex. There's definitely advantages and a bunch of disadvantages, which I'll get into near the end of the presentation. But I want to say, I'm only going to be focusing today on this particular library, and mainly I'm just going to be showing you like what you can do with it, as opposed to trying to teach you how to use it in any detailed sort of way. Mainly that's because of time limitations, but also because the deeper you get into this thing, you know, you're going to get into a rabbit hole pretty quick, because the implementation in particular is very complicated of this particular library. The guy who mainly heads the implementation and design, his name is Edward Komet, kind of a famous guy in the Haskell community. He was a mathematician before he came to Haskell, and he was interested in category theory, which, you know, when you hear people talk about Haskell, it frequently comes up because these abstractions that come from this very abstract branch of mathematics called category theory, they've had a lot of influence on Haskell and its design. When you hear these words like functor, applicative, monad, these are all concepts and sort of high-level abstractions that originally came from this branch of mathematics. And this guy, Edward Komet, having known this stuff, you can probably imagine, he was very interested in Haskell, but interested in, you know, using these abstractions for mathematics in his own work. We see a lot of that in Lens. So if we start to talk about the implementation of the library, we're going to get into that stuff, which is totally going to be out of the scope of this talk because it's just too much. So like I said, I'm just going to be showing you the main stuff of how you might use it. We're not going to get so much into the implementation. And I'm going to be mainly talking about some pretty basic stuff. There's a lot you can do with this library that I'm not going to get into. There's these concepts of prisms, folds, traversals, and isomorphisms. That stuff I'm not even going to touch on. So if this piques your interest, you can start reading online and maybe even dive into learning about the implementation. I don't even really understand the implementation of this thing, honestly. So I've just learned how to use it, and I use it in my mud that I'm developing quite a bit, and I kind of like it. All right. So later, we'll move back into the slides, but for the most part, we're going to be working in the REPL, and here I have a project I just started where we'll be adding some code to this later. Let's start in the REPL though. So let's start with the concept of getters, and I'm going to begin with tuples. If you don't know, tuples are a simple compound data type. It's not homogeneous like lists are in Haskell. We already saw it in Mark's code. It's where you have a number of elements surrounded in a pair of parentheses. So for example here, this is a pair because there's two elements in the tuple, and it has a number in the first element and a character in the second element. So one thing we can do, this is probably a good place to start with Lens, is we can manipulate our tuples. So Lens comes with a function called view. And by the way, in Haskell, you write, when you're invoking a function, the function name comes first, and then your parameters follow the way, and they're simply separated by spaces. Okay, so view is my function, and if I were to pass into it as its first parameter, _1, let's move this up a little bit, maybe. It'll let me. Okay. This _1 is the lens that I'm using here, and I'm going to use it as a getter because I'm just viewing. First, let me do this. Let pair equal 1. Okay, so now we have our pair. And if you type pair, it'll evaluate it and spit it back out. Okay, so now if I were to type view, let me view the first element of our pair. And it gives you the 1. Of course, there's an _2, which will give you the A in this case. Now the thing about this lens library is there are a handful of these nice functions like view, what is the other one? Set. And then there's a whole bunch of operators that correspond to these things. I tend to like to use the operators, and we'll get into some operators. So the operator equivalent of this view statement would be pair, and then caret dot, and then you put in the lens that you're interested in. So it's the same thing as above, just instead of view, we now have the operator. And actually, you'll frequently see people write it like this. Just take out the spaces, and Haskell doesn't have any problem with that. That's just a stylistic thing. All right, so you've seen view. The operator equivalent is the caret dot. By the way, stop me if you have any questions.
What is the _1 that is? What actually is it?
Why?
_1, is that a function? Is it a...
That is the lens that we are using here.
But I mean, what is...
I guess it would be a function, yeah.
So is there just underscore and then any number and actually...
In terms of working with your tuples, yeah. So if we have a triple, you can use _3 to get the third element. Yeah.
Is there a name for the caret dot operator?
View, I think, would be the name of it, but
So you read that pair view through the lens too?
yeah. Look at pair through the _2 lens. Yep.
If you use an _3 on a two tuple, does it give you a helpful error?
That's a good question. So this is one of the things that I was going to touch on in the disadvantages of lens. Unfortunately, you often get incomprehensible error messages. And
That makes perfect sense.
well, the reason is that this library was written in a very abstract way, and my understanding is that the compiler is doing its best to tell you what's going on here, but because there's so many layers of abstraction, it can't come up easily with a very nice, concise error message.
Thanks.
Okay, that's viewing or getting, so how about set? So again, there is a set function, set, and we give it our lens. Let's set the first lens of our pair to 2. And this just spits back the same tuple we started with a 2 instead of a 1. And of course, the pair remains as it was, right? So what we saw here is just what the function returned. We are not actually updating the value of pair. And in fact, in Haskell, all values are immutable, so you can't really mutate anyway.
So if you did like let pair modified equal set _1 to pair, that would work, right?
Pair equal modified set.
No, let say another pair underscore modified or something.
Like pair prime.
Yeah,
Okay.
equal set, that would work, correct?
Sure. And in fact, this is frequently what we do in Haskell. If we want to update pair, but when we need to assign it to a new name, so we might frequently just do pair prime or something like that.
Yeah, I would expect something like that.
Okay. Yep. Of course, we can do set _2 and B. So instead of an A, let's have a B. And I don't have to keep it a character type. I could set it to, say, the Boolean true. There's no problem with that either. Now, let's look at the operator equivalent of that. things are going to get a little weird. Hopefully you can follow along. I've been working with this library for years, so most of this is second nature to me. So dot tilde is going to be our set operator. This is the equivalent of the SET set. And you would actually, you have to have the parentheses there around the first part on the left, to the left of pair, or otherwise the compiler is going to get upset. And that probably, I don't know exactly why that is, but it probably has to do with, precedence and things.
So if you said let, if you assign to a variable the result of everything except for the pair that you just did, that would give you a function that would set on.
Yeah, you could do that. You
You
could
can
say-
show the type as well, just show.
You can do this. Now you have a nice function named f, and you could say f pair, right?
You might be called T.
Of the f.
Yeah.
Yeah. So this is a command to the REPL. Give me the type of f. Again, the types of these things can get very complicated. Honestly, I don't keep the types of these things in my head when I'm using them. I just kind of know. Again, I can't explain this stuff to you. I could try, but so yeah, this is actually an example of why this is kind of absurd. This is the problem with this library is there are 4 type variables to this type field, which in Haskell is a little absurd. And all of these mean something important at different times. And like I said, honestly, I don't know all of it, but. This is part of the reason why the error messages get so confounded, because there's so much going on here in the implementation. But it's really flexible, as you'll see.
And that first statement where you use the dot tilde, it's up a few, 6 or 7 lines. Yeah, how would you read that in English to someone over the phone?
Just pronounce it.
Well, I wouldn't really read it from left to right. I would say, take your pair and set the second field, or sorry, set the first field to 2.
If you wanted to read it more literally, I guess it would be create a function that applies the lens 1 and sets it to 2, and then apply that to pair.
Mm-hmm. Yeah. So this,
Or show them your screen.
yeah. So the fact that we have to use these parentheses is kind of, it's not very nice. So there is a way around this. There is a function that is the ampersand, that's an operator, that I think F# has this. It allows you to put the argument on the left side, and then the ampersand, and then the function you're calling on the right. So we can actually say pair ampersand 1 dot tilde 2. And it's totally the equivalent of the above.
Well, that's interesting, because in F# they changed it to a pipe forward.
A pipe fall, okay, yeah. So this is the same thing, essentially. Yeah, so this is the type signature of the ampersand function. There's 1, 2 arguments. It returns, this is the return type. So actually, I have a nice pointer. Okay. I do get presentations now and then, and I used to be a teacher too, so I used to use these in class. They're quite nice. So yeah, so it takes an A, which is, okay, it takes an A, and then this is the second parameter, which is the function. The function takes an A and returns a B. The ampersand itself returns a B, right? So it's basically, here's your parameter, which you're going to pass to this function, right? This A is this A. The function then evaluates and returns the B, which is then the return of the ampersand itself, right? That kind of makes sense?
This is provided by Haskell itself.
I think this is part of Lens, actually. Well, yeah, I'm sure it's part of Lens.
Okay.
Yeah.
So can I ask a question?
Uh-huh.
What can I buy that
I can send you the link to Amazon. Yeah, yeah. I got mine from Amazon. So
it's from?
Yeah.
That's just Flip Stolar, isn't it?
Huh?
It's just all a flip, isn't it?
I guess it is, yeah, yeah. Mhm. It's kind of handy. I use this sometimes outside of just my lens work. Anyway, when you're setting, we tend to use the ampersand. So it's a little bit easier to read, right? It's like take my pair and take the first element of that pair and set it to 2. Now you can kind of read it from left to right. All right, so now one of the things that you can do with the lens library is you can compose these lenses to drill down layers and layers into nested data structures. So we have our pair. Let's make a tuple that contains a tuple. So let's say nested is equal to a tuple that has a true as its first element and pair as its second element. And if I evaluate nested, you'll see that this is a tuple within a tuple, right? So what we can do is say, of course, if we were to say this will return true. If we change this to _2, it's going to give us our original pair. And like I said, you can compose these. So put another dot and then _1. That says give me the first element of the pair. Right, everyone follow that? And actually,
Why don't you do the caret dot?
Yeah, I was saying the same thing.
the caret dot again.
Yeah.
Yeah.
I thought caret
you
dot
don't-
was like one unified operator.
So, I mean, you could kind of think of this here, this part as your lens. And the caret dot is saying view, right? So the _2 dot _1 is a lens. So and in fact, the dot is actually the normal dot in Haskell. If you're familiar with Haskell, when we use the dot to like compose functions, actually.
So when you when you first introduced the caret dot, was that 2-character combination 1 operator or 2 operator?
Oh, that's a 1 operator. 2 characters, 1 operator.
Okay.
Yeah.
You probably could use the caret dot again. It would
Try
just be 2 separate function applications instead of creating a function and applying it.
Like this?
Yeah.
Wow, it did work. Okay.
Well, because, yeah, the caret dot _2 is just returning the value and then you're viewing again instead of creating
Right.
one lens and viewing
Yeah,
this.
that makes
So it's
sense.
probably super less efficient for big stuff, but
But I think
But the syntax be more regular and therefore you're more likely to remember.
I honestly would never have thought of doing that, but I guess you can. I don't think you would see that in the wild. I think it's going to probably typically be written like this. All right, now that was viewing. Let's try setting with our new nested. So we're going to write nested ampersand 2.1. And then over here is our dot tilde for setting. Let's set it to 2. Now here you get back the full tuple value, the tuple in a tuple, and you've only changed that one particular part that you're interested in. And the lens, the composed lens in this case, allowed you to just pinpoint that particular element of the tuple, update it, and then you get back the full value. And of course, we could do 2, set it to whatever you want, right? False or whatever. Okay, now I mentioned that there's a lot of operators in this library. If you are getting or viewing, you're pretty much, I think, always going to be using tilde dot. But if you're setting or you're somehow manipulating the data, there's a bunch of operators you could do. So for example, again, okay, so we have a number inside our tuple here, so we could do like arithmetic operations on the tuple using lenses.
Jason,
Yeah.
I'm sorry, I want to ask you this before it gets away from me. those lenses would apply equally well to the list, right?
You cannot use these lenses with lists. These only work with tuples.
Okay.
There are lenses for working with lists, and you can do things like fold over lists, and there's lenses and operators for that, or probably mapping. I honestly haven't used it much with lists. Traversing lists and doing various things.
Yeah, normally I wouldn't bother. I normally do like fold and stuff like that,
Right.
but I was just curious if they would, you know,
Yeah.
if they're solely for tuples, or would they just basically any kind of collection?
Yeah, these are, as far as I know, these only work with tuples.
Okay.
And I really, honestly, I personally haven't found much of a practical need for this library when operating with lists.
I can see that.
Some people apparently do, because there's a lot of operators and stuff you can do with this thing.
Okay.
Yeah.
So you just stick with map and fold and that sort of.
Yeah. Mhm. Okay, so there is a plus tilde, which allows you to add something. So here we're adding 1. So 1 plus 1 is 2. You get back to 2. You can subtract minus tilde. This will be 0, of course. There's multiplying. Let's multiply by 5, and it's 5 times 1 is 5. So there's that.
Are those operators just hard-coded ones, or is it magically going out and moving this? You can't just use any operator, you can only use it.
Only, this is purely what the implementers of the lens library have provided.
Okay.
Yeah.
The thing about it is that they'll tend to provide everything that makes sense once you set up a given scheme. So that goes probably more or less mechanically.
And if you add 1 to a character, it'll give you an incomprehensible error message, perhaps.
Yeah, I was planning on showing that later. Yeah, no, that's okay. Because I actually was like searching for an incomprehensible error message that I could show you, and I found one. Actually, I'm going to append a string to a number. We'll see that later. And yeah, it's really gnarly. Okay, now one lens that I use a lot is percent tilde, and maybe you can guess what it does. This lens actually applies a function to the value in the lens. So if you recall, nested first element had a true value. Not in Haskell is a function that takes a Boolean and returns a Boolean. Of course, not true is false. So that's exactly what happened here. We applied not to the true value in the first element of the nested tuple. That changed it into a false.
So what's the significance of the percent then?
They picked it.
Yeah,
Oh.
I don't know.
All right, thanks.
They try to give you some rhyme and reason behind the symbols they've chosen. Like you can see how every sort of setting operation we've done so far has a tilde on the right. If there's 2 characters in the operator, the tilde is on the right. There's some consistency. Let's import data here, and I'm going to show you another illustration of how to use percent tilde to upper. So this is pretty nice actually, because it's very concise, right? And we're going to get probably, well, I'll touch upon this later, but it is hard to read. But if you have taken the time to learn this thing, and you can use it and read it, it is very handy, because it wouldn't be, to drill down into this nested tuple and change this one thing, it would not be a single line of Haskell normally, probably, right? It'd be a little more complicated than that. So it's handy. There's also other lenses, of course. So there's a both and an each lens. me show you both. Again, this is working with tuples. So here's a tuple with an A and a B character.
I'm sorry, Jason. For those of us who aren't so deep in Haskell,
Uh-huh.
is there a separate car type and a string type, or
Yes.
so the single quotes indicates a car type?
Yes.
Okay.
And actually, in Haskell, we have our string type is nothing but an alias for a list of characters,
Gotcha. Okay.
which is kind of interesting. And then there's text, which is a more efficient implementation because the standard list of characters is not so efficient, and that's a whole other beast. But today we'll be sticking to a string as a list of characters.
I was assuming that. I just want to check my assumption. Thank you.
Mm-hmm. Sure. Yeah. Don't hesitate to let me know if you have questions. Okay. So take our pairs and both. We'll use our percent tilde again. So that's kind of cool, right? That's a little magical. Now, of course, if you have a triple, both is not going to work with the triple, but there is a each lens which will do what we want. So
Does each work on pairs?
I think it does, yeah. We can check that in a second. Each. There you have it. So let's take our, let's go pairs, which was our pair tuple, and use each with it.
You missed off the S.
Okay. Yeah, yeah. So that's kind of nice. There's also, there's a lot of cool things that you can do with this. There's a to, T-O. So I'll show you that. Let's take a, okay. If we do triple, we're going to use this with the viewing mechanism. So again, our view was caret dot. So if we look at the first element of the triple, that gives you the A. Now we can keep going and compose. So dot to lower. So this is quite similar to the percent tilde actually, but it's slightly different syntax. Well, it's actually fairly different syntax for doing the same thing. This will give you a means of applying a function to the piece of the data in the lens. You could also, again, there's a views. So we already looked at view, which has this horribly gnarly data type. There's also a views, which does something very similar to what I just showed you. So you would write views, here comes the lens, then the function you want to apply, and then the actual piece of data you're working with. So this simply says, take on my triple, apply to the first lens this function to lower. And actually, you see that this pulls out the resulting value. You don't get the whole tuple back. So if you just want to get that piece and do something with it, in this case, lowercase it, and just get that data back, you can use this views method. Same thing with to. Right, it just gave you that one piece of data, it didn't return the whole structure. All right, so let's, as I mentioned, yeah, sure.
Yeah, is it exactly equivalent to like mapping or F-mapping the result of it, or is there something more powerful going on here?
If there, I don't know if there was what like for example what more powerful thing could be happening here. I don't know.
So like instead of views underscore $1 to lower triple, you could just do triple $sign and then $1, or sorry, to lower $sign, $1 triple. So is the to lower, is using it this way more generalizable somehow? Does it account for maybe if
I don't
it's in
think
a
so.
photo or something?
I don't think so. Not that I'm aware of, anyway. Was there another question? No. All right, so I mentioned, tuples aren't the only thing you can work with. There's lists. But next I'd like to show you maps. So we have a type in Haskell called int map for key value maps where the keys are integers. I use int maps a lot in my game, so I'm familiar with them. And let's make a map. So to make a map, you actually have to specify it as a list of tuples. We use this from list. Lists in Haskell are written with square brackets, and we're going to put a bunch of tuples in here. So, for example, key 1 will have value A. So this is a int to character map. Key 2, we can have B. Let's put in a 3C. Okay, so internally this is actually represented as an int map. We just had to specify it in terms of a list. Of course, if you try to print the int map, it'll show it to you in the terms that I actually, same terms that I actually defined it. But internally it's a map. So we have a handy lens for viewing called AT. So M, and then here's our tilde dot for viewing at 1. It returns just A. So this is saying, give me the character for key 1. Now, because, theoretically, key 1 may or may not be in the map, this at lens returns the value in a maybe type. A maybe type is sort of a wrapper. It's a just or it's a nothing. So it's a just something. In this case, it's a just A. Or if it's not there, like let's say 0, we get back nothing. So this is sort of, a way to nicely work with something that may or may not be there, right? It's not going to crash the program if the key isn't there. Now we can actually use the at lens to do setting as well. So let's say M at 1, and then we have the dot tilde for setting. Now we have to wrap the value we want to set in a just in this case. Let's do Z. So where there used to be an A, now there's a Z. Now, what if we put a nothing in there? Well, then it just totally eliminates that key value pair from the map, deletes it. So that's kind of cool.
So you're changing the map.
We are not mutating the map. We're not.
Makes a new map.
Okay,
We get
that's
back a new map. Yeah, we get that. Which you can see. If I say what is M, the original M gets stripped back. Yeah. All right. So far, so good. Now, I'd like to show you how you can use lenses with your own data types, specifically with record data types. So as I mentioned, I'm working on a multi-user dungeon. It's a all-text game, runs over the Telnet protocol, or loose implementation of it. But it's kind of like a virtual world. It's a little bit like an MMORPG type of thing with a fantasy setting. You've got a character, you're running around, and you're killing monsters and collecting treasure, interacting with other players, and so on and so forth. It is all text. which makes it different than the more popular graphical games. But these games were very popular back in the 90s. They still have a dedicated player base. So let's sort of do something along those lines, right? Let's say we're writing our own HUD. So let's say we're going to define some data types. Ultimately, we're going to make a weapon. But let's assume that our game is fairly complicated. We may have weapons and armor and monsters and all kinds of things. So a weapon is probably going to have various, a weapon may have a name, a description, a weight, and a volume. Other things may have weights and volumes. So we may want like different data types to represent each part of these functionalities. So let's start with an entity. This is a record data type, so we get to define records. So entities, which is going to be like our base type, the most basic thing that probably all objects are going to have in common. Everything will be an entity. We'll give it a name, which is a type string, and a description, which will also be the type string. So if you don't know Haskell, this isn't too complicated. I've just made my own data type, and it's a compound data type with two strings in it. Right? One is a name, one is a description. And we are going to derive show, which basically sort of gives us like a free two-string for this type. What that allows us to do is, if I go over here, let me reload, which will load the code I just wrote. What is my Emacs doing over here? Lock. I'm going to steal it. Okay. So we can say, we can define an entity with a name, sword, description, big sword. Do I? Yeah. Anyway, like all of the deriving show thing did us is it just allows the REPL to print this out for us. It gives us a printable like representation of the type, just like kind of two-string in Java. So anyway, that's what that did. So we have our entity. It's got two different records in it. Let's then move up or down one layer of the hierarchy and make an object, which will have weight. We'll just say that's an integer, that'll be pounds. And let's have a volume, which will be like maybe cubic inches. Now we also want our object to have an entity because all objects have an entity. So we'll make an entity field of type entity. Do that and show. So you can see we're nesting types, right? Because we have an entity inside an object, and I'm going to end up showing you how to drill down into these different nested types. But before that, let's make our weapon type, which will have an object and damage. And the damage will be a range, which we will represent as a pair tuple with a minimum damage and a maximum damage that it can do.
Jason, another question for you. In F#, you can't use things until after it's declared. Is that true also in Haskell, that you have to declare entity before you can use it?
No, it's not. No, that case in Haskell, yeah. Okay.
I asked, it seems like they borrow a lot of ideas from Haskell and F#.
They probably did. Most languages these days, it seems, have borrowed something from Haskell.
And some of the people who worked on Haskell now work on F#.
Yeah. Okay. Yep. All right. Let's make a sword, kind of like I did in the REPL, but we'll make this more of a fleshed out sword. So we start with this line. This is simply the type signature for this thing that we are naming sword, lowercase s. This just says sword is of type sword, capital S. Capital S sword is the type that we, oh, whoa, no, this needs to be weapon. We don't have a sword type. We have a weapon type here. So sword is of type weapon. That's all that that line does, and then we're actually going to define it here. So sword is equal to a weapon. Now, this is going to get a little bit gnarly here because of all the nesting. So that's the entity. Objects also have weight. We'll say it's 2 pounds. And the volume, we'll say, again, this was cubic inches, so let's say it's 3 by 2 inches deep by 20 inches tall. That's the object. Now we have the damage field. It does between 5 and 10 hit points of damage.
Closing quote on sword up
Probably closing quote on sword. Oh, yep, thank you. Yep. Okay. Let's go back to the REPL, reload. All right, that's a good sign. Now, okay, there's our sword, and because every one of those types has a deriving show, it can print it all out for us. So very good. Now, let's start using some lenses. Well, first of all, actually, what I'd like to show you is what this normally looks like in Haskell if you want to poke around with this type of nested data type without lenses. Because here is where lenses actually really start to shine, because this is kind of cumbersome to do in Haskell normally. So for example, now I should take a step back and say, when you define data types like this as record data types, you have these fields, right? For example, entity has a name and a description. And when you do this, Haskell will actually give you functions of the name of these fields for free. So if I have, let's see, I have my sword. So for example, I have a damage field, it's part of weapon, and I actually have a damage function too, DMG, which takes a weapon and then returns the value in its damage field. So if I were to say, what is the damage of my sword, it should return 5, 10. So that's kind of nice, but let's say that I want to drill down into the object level and change the weight of the sword, or really technically get back a new sword with a new weight. I can say, take my original sword, and I'm interested in the damage field. Let's change it. It was 5 to 10, so let's do 10 to 15. This is called record update syntax. It allows you to simply specify in these curly braces the field that we're interested in this case damage. And we want to take our original sword and simply change the damage and keep everything else of the sword as it was. And that's what the syntax does. That's exactly what happens. And that's nice. So far, so good.
So now you're changing the attributes of the object rather than making a new copy, is that true?
No.
Everything is always
Okay.
Don't call it an object for one thing. Yeah, nothing's permanent to you. Assign it.
a lot of memory.
Yeah, generally speaking, everything in Haskell is immutable. So you cannot actually change the value of the sword.
So when you were saying you were changing the damage of the weapon, now there's a new.
Yes.
Yeah.
Okay.
Like I said, I'm just kind of, technically I shouldn't say I changed it.
Well, I'm just trying to
Yeah.
understand.
Yeah,
So, thank you.
It's kind of, yeah, we typically might say you change or you modify, but really you're not modifying the original piece of data at all.
The English language is a very good deal with naval objects.
Right.
In effect, you're getting a temporary weapon that the REPL is showing you.
Yes.
And interestingly, it will be sharing most of the structure with the other ones. So even if you had thousands of these things, you can only change one bit. You're saving most of the space and memory.
Okay, so far so good. This wasn't much of a big deal, right? This is nice, this is easy. We changed the damage. What about if we want to manipulate the weight? So damage is a field of weapon. Weight is a field of the object. So we will have to drill into the object that is here, right? This is the object of the sword. We have to get inside that and then mess around with the weight. So here's where things are going to get a little bit funky. And in fact, we were able to say DMG sword, and it gave us back the damage, but we cannot say weight of sword, because sword is not an object, it's a weapon. Weight is a field of object. So what we could do, though, is do a little composition. So this is composition in Haskell. This itself basically is a function composed of the object and the weight functions, and you can kind of read it from right to left, right? Like take your sword, give me the object of the sword, and then take the object that's returned from this and apply that to the weight. The weight then will give you the weight of the object. Well, if we want to update the weight using record update syntax, this is where things start to get really nasty. And this is one of the kind of shortcomings of Haskell, is that this record update syntax is kind of funky. This is how you would do it if you really wanted to or needed to. Yeah. It's kind of like this. If we look at this line first, this is an easier line to review. Take your sword. Oops. Take the sword. Keep everything in the sword as is, but only change this up to this damage. Now, we want to do that, but only change the weight. So we actually have to take our sword and then go one layer into the object. And we want to keep the same objects that we had, but only change the weight. And to do that, we actually have to apply the object function to sword. And then we have an object to which we can change the weight. So if this is confusing, I don't blame you. It's not easy to read and it's pretty confusing. So here's where lenses come to the rescue.
Yay.
Yeah. So, okay, already Mark has been talking about template Haskell, and we're going to use some template Haskell here, because a nice thing about the lens library is that you can use template Haskell, which is again the, what is it called? Quasi-coding and, I forget the correct word. It's code that manipulates code, or code that produces code, right? So we can use template Haskell to generate.
Metaprogramming.
Huh?
Metaprogramming.
Yeah, metaprogramming, thank you. Yeah, metaprogramming. We can use metaprogramming, in this case template Haskell, to actually generate lenses for us corresponding to all of the records in these types. But first thing I have to do is enable template Haskell by putting this language pragma here at the top. Okay. And we have these handy functions we can put, and I'm pretty sure that we do actually have to put these at the bottom, which is a quirk of the metaprogramming. This is just saying, make me lenses for my entity type, for my object type, for my weapon type. Now the only thing that we have to do though, which is just a requirement of how this all works, is we have to put an underscore in front of our names now. And that's how I think the template Haskell knows what it needs to do.
So if you don't put the underscores, does it raise an error, or does it just ignore those?
I don't know. We can try and see.
So it must be actually proposed.
Suggesting.
Well, it's not happy anyway.
Yeah, if it wants the underscore. That's
Yeah.
it must be actually.
Seems like we could have figured it out.
You would think.
Let's be lazy.
Oh, well, yeah.
It's probably putting the non-underscored versions in for you, so these have to not be named, though, that they be overwritten.
Okay, I think we should be good. Yes. All right. Okay. So again, here's our sword. Now we can say sword caret dot DMG. This, of course, isn't anything terribly special because we can really just do this, right? Without one, or no, sorry, sword. What did I do wrong? Oh, no, I have underscore, don't I? I have the underscore. You're right. Okay.
Yeah.
Yeah. So the lenses it produces don't have the underscore. But if you want to use the fields like you would normally do in Haskell, you have to put the underscore there now. So, a little unfortunate. We can now update or set. We can do cool things like, let's say, so the damage is 5 to 10 hit points. Let's double it, which we can do by using our both lens. And in fact, we can do that, multiply times 2, that'll double it. Now at the bottom, damage is 10 to 20. We can drill down into the object. Let's view the weight of the object. That's nice. We can go even further into the entity. Okay. Entity. View the name. We can then.
So you still gotta know a little bit about the hierarchy, but not as much.
Yeah, you have to keep the hierarchy in mind, but this just gives you a handy, concise way of drilling down right into it.
Yeah.
If you want to,
right away, you just store the composed lens.
you could do that. You certainly can. That should be doing it like this. No?
No, it's because you imported in math there without a.
Oh, I've got an import issue.
You just did prelude.map, I think that's what you're looking for.
Okay. Yeah, I probably should have done qualified import of data int map, but oh well. So that capitalized the name. We can even, there's another lens that I haven't showed, or an operator I haven't showed you yet, which is this with a tilde. This will allow you to append. Now we have a sword of thunder.
Whoa.
Yeah, the sword just got a lot cooler. If we want to change like different, more than one thing, what we can do is just keep adding ampersands and keep going. So for example, let's rename it to Sword of Thunder and multiply the damage. What else could we do? We could take, I don't know, you get the point. So, yeah. So anyway, this is a lot nicer than, I personally think it is, you know, nicer than the normal record update syntax, especially when you're dealing with layers of nested record data types.
The question back here.
Yes.
So what did people do before lens?
I think that they just had to make do with the record update syntax. And
also the people invented lenses. Yeah, that's true, yeah.
There's been a bunch of attempts of doing different things that are not particularly satisfactory.
Yeah, but then one thing that you didn't mention is that AdConnect wrote basically 50% what's in package. Like 50% of the source code in package is wrote by this guy that I'm stalking. So if he's in the area, I'm going to bring him here if possible.
yeah, that would be cool.
But no, yeah, that's the thing. Everybody attempted because it's very painful. If you show the code, yeah, the way you know the Haskell is very painful.
I mean, there's other problems with it as well, in that if you've got a name as a record label in a record, you really better only have it in one data type.
Yeah.
Nothing else can have a name.
Right, so in my game, I would actually call this ent name, ent description.
Right, it ends up like basically Hungarian notation.
Yeah.
It's not a bad.
Yeah. Yeah, like overall, there are some warts with the records in Haskell, and people are working on trying to find a nice way to fix it. Actually, the latest version of Haskell has of the GHC compiler. I think it will allow you to actually have more than one data type with, say, a name record. And I'm looking forward to trying that, but I can't get my mod to compile with the latest compiler yet because of some issues with libraries not matching up that actually I'm probably going to see if Mark will help me with after this. Okay. So that was pretty much the code that I was going to show you, so we can just kind of wrap it up here with...
So the lenses that you had were specifically related to the, I don't know what the right word is, the entities and the things that you, the data types that you created.
Mhm.
So other things where you, I think you had some examples where you could add like a tuple inside a tuple
Mhm.
with a lens operation. That wouldn't work with this, or would it?
Yeah.
It would. Oh, okay.
Like if you had a record in one of its fields, you could sort of drill down to that record and then inside the strip bullet, it all plays
Right.
well together.
Okay. All right.
Yeah, they're quite composable, which is nice. As long as the types line up, then you're good. Yeah.
I could really see something like that being extremely handy if you had to work with JSON.
I was going to say actually there's two packages, there's HTML and I think Lens ASON.
Yeah, there is. That's right.
It's super useful, especially if you get some big hairy
Yeah.
object and it's like, oh okay, and you just iteratively go through it. Say, okay, cool, this is the chunk I want, and it's very very quick to use.
Yeah, I could say that I've seen some honking huge JSON return from APIs. Yeah.
Yeah, so these are the advantages. It's concise, it's expressive, it's flexible. We saw tuples, int maps, nested record data types. You can compose them. this is, I put the star here, because this is really the main draw of the library, I think. This is better than the Haskell normal way of doing it. And there's other stuff that I wasn't able to touch on, like they play very nicely with the state monad, which kind of allows you to get around Haskell's immutability in sort of elegant ways. So you can do things like you can keep a running state and sort of update it. Without getting into that, that's a whole other thing that I'm not prepared to talk about today. It's outside the scope. So this, as you've already seen, this is not, there are some serious disadvantages with this. So the library is very cumbersome. It has many dependencies. It's kind of like, it's a bit like a domain-specific language with no specific domain, right? It's just, it's like a batteries-included library, and there's 50 pounds of batteries with the thing. So this is a drawback for people who are concerned about their compile time or how big their
it's
bloat,
so
right?
widely used now. If you pull in something like this, or probably many others, you're getting a copy of Lens somewhere, so you might as well.
Yeah, I mean, yeah. Here's a big one. The library has too many operators. So I have what happened to the formatting?
CSS is optional.
Where is the CSS? Oh, I'm not connected to the internet, am I? Can I get on the internet?
Yeah,
I'm sure you can, it's open.
the lobby, the third one.
Good luck, it didn't work for us.
Right, okay, so hopefully this will show us the documentation for the library, specifically the part of the library that has all the operators in it. And there are so many operators, it's a little absurd, it really is. We'll just kind of scroll through this. Right? Every one of these is an operator. And as you can tell, so here's our getter. We saw this one. What does this do? View the index and value of an index getter or indexed lens. This is the same operation as iView with the arguments flipped. Of course it is. Everyone knows that. There's like I'm not even like a third way down yet. There's our and, which we've been using. Yeah, it goes on and on. So everything that you would want to do ever, there is an operator for it. So not surprisingly, some people say this is a little too much. I certainly don't use. Actually, the operators I showed you today, those are the main ones I use typically. I don't use any of this stuff. And how, it begs the question, like, who's going to remember what this actually does if you were to encounter this somewhere, right? Like, modify the target of a lens in your monad state by subtracting the value and return the old value that was replaced. Yeah.
It's a monad.
Outside the scope of this talk.
Nobody knows.
Control freeze out.
All those operators is job security, man.
I just did a Google search on Lens, because I think it's something outside of this particular library. It's going to come on MacBook. It says, the gist of a lens is a function that executes a series of steps to get an intermediate result, performs an operation on that intermediate result, and follows a series of steps backwards to build up a new result. And they give, it's type signature consisting of 4 types of micronotated.
Yeah.
I would not read it poorly, but it just seems like it's a very generalized way of dipping into an object and extracting something,
Right.
transforming it, and rewrapping it up.
Yep.
And libraries exist for doing similar things in any language you want.
Yeah, this was from pure script.
Yeah, someone's probably written it in whatever language you're using.
Is there
documentation and F-sharp use
is there like an object-oriented equivalent of this type of getter and setter lens? Not that I know of.
The thing is, I think the value is less in a lot of languages because you don't generally trust. You never really trust that you've got some immutable object or sort of something you can just afford to keep it. If you've been trusted at some point and you want to use it later, you almost always figure, okay, I'll decopy this thing because who knows what somebody else is going to do to it. So without that, you know, you'd need to be using Lindsay stuff everywhere, and there needs to be this informal agreement that, you know, you don't change stuff.
I've run into situations where you do use it, especially when you're like dealing with APIs to get it based on, like if you're like parsing through objects, you generally just define a method to get the thing that you want from the thing, which calls the method that gets the thing you want in that thing. But with parsing through like JSON stuff from the response, it's really helpful to have some efficacy when you're in an OO language.
But then you can't just index it. Oh, I guess you don't want to change it when you want to create a new version. Are you talking about
When you're doing the update, when you're just getting stuff out of it, usually the syntax is a lot better because you're not in Haskell. When you're actually wanting to set things or mutate things, or if you're doing some immutable stuff, then usually it's helpful to have something that you can close together, you know, the lens and then
Even when there is mutability, one benefit might also be like, I think lenses have the ability to return things that you can map over, so you can say, you can have something that matches multiple things within a structure and then apply a function to those multiple matches and then build that back up. And that there's nothing like that in like standard code.
You guys just gave me a great idea for a blog posting. A Heisenberg getter. When you observe it, it changes it.
Yeah, so it just, this is another disadvantage, we've already mentioned it, but yeah, the implementation is very difficult to understand, and Edward Comet, being the category theory guy that he is, you know, he wanted to, category theory is I think the basis for a lot of the abstractions of how it all works. You can already see functor here, but anyway, yeah, the 4 parameter type is kind of crazy. You don't typically see that. Oh yeah, and the incomprehensible error message. So let me show you that. We've already seen it, but let's see what this does, right? If we take, let's take a tuple that has a 1 and a 2, and over the first field, let's try to append a string. And you would think that the error message would say, oh, you can't append a string to a number because Haskell is very strongly typed. You know, it's not like JavaScript where it'll convert the number into a string or something. It doesn't do any of that for you. But no, we don't get an error message like that. We get this. So yeah, we've got functors, we've got general categories. Yeah, the compiler is just doing its best, but it's so confused, right? It's like, I don't know.
What happens if you just try to take the type of that?
The type of what?
A column C of that rather than trying to actually push that in.
Yeah, it's just reference memory.
Like, oh, of this?
Yeah.
Pulse expression?
just a BT, where B is a mono. That's why if you do like with 1 instead of Hello, that should be 2, right? The result. Because it's a mono.
Yeah. Oh.
If you do 2, this is a append, right? Oh no, without the type.
Yeah.
Oh, doesn't like it.
No.
But because you can't find a concrete thing.
Oh, because we need to specify the role maybe plus on the number. Yeah. As the operator.
Oh, it depends on the kind of monoid you want to have.
Exactly. You need to import a monoid or specify the monoid.
But it's something shown off.
So you can tell the guy came from a math background because the lens is _1, not _0. You know.
So yeah, I mean, like Mark was saying, this is a very popular library. It is used a lot, and I tend to like it. But you know, for me, what I'm doing is I'm developing a game by myself as a hobby in my own free time. I'm not writing code that anybody else has to read. You know, I'm doing it for myself, really, just for fun. I'm just a hobby programmer, so I have no problem using this library that, you know, not every Haskell programmer is going to be able to use or read, that has these horrible error messages. And like I said, I never even had to dive into how the implementation actually works. I just learned how to use it, and I get a lot out of it. So, but, you know, if I was writing a library for other programmers to consume, I wouldn't be I'd be a little bit hesitant to go and start, throwing in every operator in the kitchen sink from, into it, or even using the library to begin with. So anyway, yeah, that's it. Any questions?
Thanks. Yeah, very quickly, last couple of announcements and you guys are free to go. You go?
So while he's occupied, I'd like to say, let's thank Felipe for putting this together.
Thank you. Okay, there's nothing here. So, here we go. We do the talks. So, at the end of our meetup, we always do announcements to other meetups. I don't know if you guys are part of other meetups. I heard PyData here somewhere. So yeah, anyway, this month we have, just send me a slide or two, I can just publish here. So we have Danielle from SE, it's like Southeast Michigan, right?
I call it Sundance, but it's Southeastern Michigan Healthcare Group.
And you guys meet?
We have a presentation on the second Monday of every month, and a study group on the first Monday of every month. That's the
study group.
Yeah, that's the study group. And yeah, the study group is really just informal. We don't get together. We can bring projects we're working on, talk about JavaScript. It's just really us all getting together and supporting each other with our JavaScript measures.
We also have one category here, don't we?
Have we? Well, if we have, it's because you brought it up. So, and then the talk is on TypeScript, I think, is that looks like.
Before?
Yeah, that one.
Yep.
So, yep. So.
Okay. Any other meetup you guys want to advertise?
We host an Elixir meetup over in Detroit.